Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, how are you doing today? I hope you all doing fine. So today in this video, me and my group members will try to explain you about descriptive statistic. But before we move to the material, let me introduce you to the members of the group. The first is myself, my name is Widya Sari Ismail. The second is Sulfitriani, and the last is Indah amaliah. That's all for introducing. Let's jump to the point. Statistic is the collection and organization, interpretation of data, and there are two broad categories within this field: descriptive, in which you present and organize and summarize your data, and interferential, this is where you run different tests and draw conclusion about your sample that we can impute to a population, provided that our sample is representative of the population. But today, we will just focus on descriptive statistic. So, we will see what descriptive statistic means. Descriptive statistic is the values that describe the characteristic of a sample or population. So we run descriptive statistics so that we can describe the characteristic of our sample and infer that to the larger population. So we summarize, describe, and characterize the sample being studied. We determine if the sample has a normal distribution or bell curve, and most statistical tests require the sample to have a normal bell curve shape. We determine if the sample can be compared to the larger population, and we display descriptive statistics as tables and chart percentages, frequency distribution, and we report measure of central tendency. Descriptive statistics include the following information about a central tendency: mean or average, the median or midpoint, and the mode, the most frequently occurring number. We would also measure the variability in our sample, the range, which is the differences between the largest and the smallest variable, and variance, how far the number are spread out, and standard deviation, which is how much variation exists from the average and the sample mean. Skewness will let us know how symmetrical the distribution of variable are for each other. Skewness will let us know how symmetrical the distribution of the variables are for each one of those categories. And kurtosis will let us know if the data is peaked or flat. If it's peaked and a lot of the sample is very similar, it is more flat, then we have a wide distribution or a different subject in our sample. Shape or curve of the numbers will help us to understand if we have a frequently occurring number, there are outliers, and if the data is skewed. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. As such, measure of central tendency are sometimes called measure or of central location. When we speak of the mean, the most common average, we refer to it as the arithmetic mean, which is the sum of the observation divided by the number of observations. It also referred as the balance point of the dataset. In symbols, some use M, but to differentiate the population and the sample means, we use Greek letter, which is mu for the population and X bar for the sample mean. Consider here that N as the population size, and the largest L, N as the population size, and the smallest N for the sample size. Okay, you can read the example here. Since it was stated that these are randomly selected customer, then we are sure that these are from the samples. And given these 5 observations, then the value of our smallest n is 5. And since we are asked to find the mean age, then this revert to the sample mean, which is x bar, which is the sum of the observation over the number of observation, which is equal to 5, and getting the sum of 19, 25, 32, 27, and 41 divided by 5, that give us 28.8. Thus we can say that the mean age of this customer is 28.8 years. In another example, a researcher wants to determine the cholesterol level of all 6 residents of Guyan Island. And we were asked to compute for its mean. And since it stated that all these, the 6 residents, then these are the population. And since we have 6 observation here, then the value of the large n is 6. And since we were asked to compute for its mean, and this is about the population, then we are going to use this formula. The next we have median, which is the middle value of the dataset. Thus it separates the data into lower half and the upper half. The next is how to determine the median. First, arrange the observation in an ascending order, and actually there are 2 kinds of the median according to the year number. The first is if the number of observation is odd, the median is the value at position n plus 1 divided by 2. And if the number of observation is even, so we need to determine 2 position. The first is n divided by 2, and the second is n plus 1 divided by 2. And then the last is find the average of the 2 values to get the median. And here is the number of all observation. And if you want to determine the median of group frequency distribution, you can use this formula. The mode is the most frequent score in our dataset. On a histogram, it represents the highest bar in a bar chart or histogram. You can therefore sometimes consider the mode as being the most popular option. Normally, the mode is used for categorical data, where we wish to know which is the most common category, as illustrated in the histogram. We can see that the most common form of transport here in particular dataset is the bus. So we can say that the bus is the mode from this histogram. So this is the formula for computing mode from a group frequency distribution. Okay, that's all from me, and the next material will be explained by Sulfitriani.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sulfitriani, and I will continue to discuss about measure of variability. And there are 3 points in it. First is rate. The second is standard deviation and variance. Okay, range. The first is range. Range is the simplest size of the spread. The distance is the difference between the largest and smallest value in a data group, but population, data, or samples. The smaller size of the distance shows a better character because it means the data is close to the center and compact value. Next is rank for non-group data. We can see from the slide there are examples for ranks data or loss data. Okay, next is rank for group data, and the example you can see from the slide. And the last is standard deviation. Okay, standard deviation indicates the degree of variation in the data set from the mean. The standard deviation is used to show how different the existing data is compared to the average of the data itself. Yes, I think we can see the population standard deviation and the sample standard deviation from the slide, guys. Okay, next is variance. Variance and standard deviation is a measure of the spread that shows the standard deviation or deviation of the data from its average value. The variance is the calculated average of the squared deviation of each data to the calculated average. The variance can be distinguished between the population variance and the sample variance. The population variance is the squared deviation of each data set against the calculated mean of all data in the population. The sample variance is the square deviation of each data mean counts against all data in the sample for which the sample is part of the population. Okay, I think that's all for me. Next is my friend will try to read the next material. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I'm Indah amaliah and I'm going to discuss about skewness, kurtosis, and shape. Okay, let me to discuss about skewness first. Skewness is a measure of the asymmetry of the probability distribution of a real valued random variable about its mean. The skewness value can be positive, zero, negative, or undefined. The second one is kurtosis. Kurtosis is a measure of the tailness of the probability distribution of a real valued random variable. Like skewness, kurtosis describes the shape of probability distribution, and there are different ways of quantifying for theoretical distribution and corresponding ways of estimating it from a sample from a population. The kurtosis of any univariate normal distribution is 3. It is common to compare the kurtosis of a distribution to this value. Distributions with kurtosis less than 3 are said to be platykurtic, although this does not imply the distribution is flat-topped, as is sometimes stated. Rather, it means the distribution produces fewer and less extreme outliers than thus the normal distribution. Some authors use kurtosis by itself to refer to the axis kurtosis for clarity and generality. However, this article follows the non-axis convention and explicitly indicates where axis kurtosis is meant. Alternative measures of kurtosis are the first, the L kurtosis, which is a scale version of the fourth. L moment measures based on fourth population or sample quantized. These are analogous to the alternative measures of skewness that are not based on ordinary moments. And the last is shape. A shape is the form of an objective or its external boundary, outline, or external surface, as opposed to other properties such as color, texture, or material type. Some simple shapes can be put into broad categories. For instance, polygons are classified according to their number of edges as triangles, quadrilaterals, pentagons, and so on. Each of these is divided into smaller categories. Triangles can be equilateral, isosceles, obtuse, acute, scalene, and so on. And other common shapes are, the first is points, lines, planes, conic sections such as ellipses, circles, and parabolas. Among the most common three-dimensional shapes are polyhedra, which are shapes with flat face, ellipsoids, which are egg shapes or spear shaped objects, and cylinders and cones.
Okay, because she is the last presenter, and I think that's all from our group. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.